All right, this next section here is continuing on voltaic cells, just talking about cell notation. Okay, so chemists have developed a shorthand method for representing voltaic cells that we call cell notation. In the cell notation, the following rules apply. Again, so like when we look here, okay, the anion is always on the left, or the anode is always on the left, okay, then their cathode is on the right. So, and again, the anode and cathode are always the electrodes, like the solids. Okay, even if like they aren't, like the cathode is where the oxidizing agent is the oxidizing agent, it, but it's that actual cathode is the metal. Okay, a single vertical line represents the phase change, so that's this vertical lines here represents the phase change between boundary between the electrode and the solution that's in that half cell. Double vertical line represents the porous barrier or salt bridge between the two half cells. Okay, and then inert electrodes do not appear in the chemical equation or in the half reactions, but they are included in the half cell notation. So I'll see both of these have neither of them have inert electrodes, but we'll be doing some examples later on that show that. And then a comma separates formulas in a half reaction to indicate that they are in the same phase. So if we have more than one thing in our so if we have more than one solution, we just put a comma around that solution, or like next to that solution. Okay, so this is just showing for like this half cell here. Okay, so copper is our cation. Okay, zinc would be our anion, so the electrons are going to flow from copper or from zinc to copper. Okay, the anions in here are going to flow towards the anode, cations towards the cathode, and so we have our two different half cells. Okay, this is just showing like with taking away the nitrates, which are just spectator ions. Okay, what's happening? So overall, like we always have our anode, okay, our cathode. Doesn't matter which side you put them on. You just make sure you always label as your cathode is positive, anode is negative. Okay, and electrons are always flowing towards the cathode, and then label your direction of your cations and anions. Okay, so now we are looking at, oops, moved to the wrong spot. So now we'll do some examples using pen and paper. All right. Okay, so write the equation for the half reaction and the overall reaction that occur in the following cell, and then draw a diagram of the cell, labeling electrodes, electrolyte, direction of electron flow, ion movement. Remember that carbon graphite is inert electrode. Okay, so again, so we have our two electrodes are carbon for both in this case. And so really those are both going to be inert. They're still our electrodes. Now we have to figure out which one's anion, which one's a cation based on what's happening with that electrode. So again, we look here, okay, dichromate and hydrogen, when mixed together, are oxidizing agent, and Fe2 plus is, so Fe2 plus is an oxidizing agent and a reducing agent. Okay, again, just using our table here. Okay, so it could be a reducing agent. Here it could be an oxidizing agent. That's how we know dichromate and hydrogen are oxidizing agent. Okay, and then Fe3 plus is an oxidizing agent. Now we have to figure out what's our strongest. So this is our strongest oxidizing agent. This is our only reducing agent, really, in this case. Okay, and so we want to write the half equation. So again, just looking out of our book, we write the equation of our strongest oxidizing agent just like we see it in the book. So this is what it should look like. Okay, and then we are going to write down the oxidation half reaction for iron 2. So iron 2 plus produce iron 3 plus and 1 electron. Okay, it's helpful now too to label it like this is our strongest oxidizing reagent. That happens at our cathode, so this is going to be our cathode. Okay. And then this will be our anode, which will be helpful later when we're drawing them out. Okay, we balance it out. We need to balance the electrons, so we're going to times everything in here by 6 and write out our balance reaction. So this is our balance reaction, what it should look like for part A. So yeah, this is part A. That's done now. Okay, part B, we're going to draw a diagram of the cell, okay, labeling the electrodes, the electrolytes, okay, the direction of electron flow, and the direction of ion movement. Okay, and we're going to remember that, again, graphite is the inert electrodes. And so we'll just start drawing 2 beakers, okay, and then 2 electrodes. These are the metals. Okay, these are carbon, solid for both of them. Change this. There we go. Okay, we have they're in solution, so we'll just kind of solutions here. Okay, those solutions, and here we have Fe2 plus. We also have iron 3 plus. Okay, over here we have Cr2O7 2 minus and H plus. So again, it doesn't matter which side. Then they're connected by salt bridge. Okay, they have the little plugs in them. Again, just to let the ions through and not to let these ions go back. The cations in the salt bridge are going to go towards the cathode. Okay, the anions will go towards the anode. Yeah, and so yeah, we wanted to label diagram the cell. So yeah, the carbon is our cathode. Okay, remember, cathode's always positive, anode's always negative. Okay, the carbon on this side is our anode, but like again, we know this is the cathode because it's where the oxidation reaction's taking place. This is the anode because it's where the reduction, or sorry, this is where reduction's taking place. This is where oxidation. This is where our oxidizing agent is, and this is where our reducing agent is. And then they're connected by external circuit. And we always want to show electron flow, so the electrons are going towards the cathode. And we'll just make sure we got everything. So it says, yeah, draw a diagram of cell, so label electrodes, we did that. Electrolytes, this is what we have. And here too, this would produce some Cr3 plus as it's going through because that's a product. Okay. The direction of electron flow, so the electrons go from anode to cathode, and the direction of ion movement, so anions towards the anode, cations towards the cathode. Okay, so this will give you full marks for drawing this voltaic cell in this case.